Hello everyone. In this lecture, I am going to cover the second algorithmic transformation technique, that is unfolding. First transformation technique that I had discussed was retiming. Now I will cover unfolding. So unfolding is a transformation technique that can be applied to a DSP program to create a new program describing more than one iteration of the original program. So consider a DSP program given by the equation yn is equal to a of yn minus 9 plus xn, and its block diagram representation is shown here. The value of n is from 0 to infinity. Now let n is equal to 2k and 2k plus 1. So for n equal to 2k, the equation is a of y 2k minus 9 plus x of 2k, and for n equal to 2k plus 1, the equation is y of 2k plus 1, that is equal to a of y 2k minus 8 plus x 2k plus 1. So together the two equations describe the same program described by this first equation. These two equations are describing the two consecutive iteration of this program. So this can be verified for any value of n. So let's say n is equal to 10. So y of 10 will be equal to a of y1 plus x of 10. Okay, so this is describing a iteration for n equal to 10, and for n equal to 11, y of 11 is a of y2 plus x of 11, and this equation is also describing the iteration next to this one. This is for n equal to 10 and this is for n equal to 11. So I can say that this is, let's say, 10th iteration and this is 11th iteration. And if n is 10, k will be 10 divided by 2, that is 5. So for k equal to 5, y of 10 is a of y1 plus x of 10. So this equation is same as this equation, and y of 11 is equal to a of y2 plus x of 11, and this equation is same as this equation. So these two equations together are describing two consecutive iteration of this program, and block diagram representation for this two equations is shown here. So it is called two unfolded version because we have drawn for two iterations, two consecutive iterations of this program. So two factor comes from this number of equations, consecutive equations that we are writing, and unfolded. So we have unfolded, it's a two unfolded version of this equation. So there is another popular name for unfolding that is called loop unrolling, and that is mostly used by software engineers. So before explaining this circuit, I will like to explain the concept of delay in unfolded architecture. So in unfolded system, that is unfolded j times, each delay is j slow. Okay, So we have written two different equations. So first equation was for n equal to 2k and second was for n equal to 2k plus 1, and two samples will be provided simultaneously to the system. Okay, so x of 2k at this point and x of 2k plus 1 at this point. Okay, so let's say that this is port A and this is port B. So initially x of 0 will be provided at port A and x of 1, that is next sample, will be provided to port B. Okay, so this is the sequence of samples. X of 0, 1, x of 2, x of 3, and so on. So starting with x0, sample will be introduced to the system one by one. So, since we are giving two samples simultaneously, so x0 will be given at port A, x1 will be given to port B. So x0 and x1 are given simultaneously to the system. So after the completion of iteration corresponding to the samples, the system will be provided with sample x2 and x3. So x2 to port A and x3 to port B. Okay, and after that x4 and x5. So if there is a delay element in between in the circuit, in unfolded version, that is unfolded by a factor 2, so if the input to the delay element is x2, okay, so the delay element would have x2 the sample previous to x2, that is x0. So if the input to this delay element would have been x3, so the sample stored in the delay element would have been x of 1. So there is a difference of 2. So for unfolded system, that is unfolded j times, the delay element is j slope, means that if the input is xk, the stored sample and output of this delay element will be x of k minus j. So now based on this concept, this circuit can be explained. Okay, so y of 2k is x of 2k, so x of 2k is coming from this source, and the second factor is a into y of 2k minus 9. So the second signal is coming from this point. Okay, so this is multiplied by a, and at this point the signal is y of 2k plus 1 divided by 5d. So y of 2k plus 1, and that is delayed by 5. Okay, and since this is 2 times unfolded, so this 5 will be multiplied by 2, so minus 10. Okay, so if I take k equal to 5, okay, so 5 into 2 is 10 plus 1 minus 10. So this is y of 1. For k equal to 5, this is y of 1, and this will be x of 2k, that is 10. Similarly, at this point, y of 2k plus 1 is summation of x of 2k plus 1 coming from this source, and second input is coming from this point, that is also multiplied by a, and at this point y of 2k is delayed by 4d, so y of 2k delayed by 4d, so 4 into 2. So for k equal to 5, for k equal to 5, this is y of 10 minus 8, that is y of 2. So for k equal to 5, this is y of 2, this is x of 2k plus 1, that is x of 11, and this is y of 11. Okay, so hence this circuit is representing these two equations verified. So based on this discussion, unfolding can be loosely related to parallel processing. Not exactly parallel processing, but a kind of a parallel processing. Okay, and so now we will see step by step so how to achieve the unfolded structure from the given one. So step 1 is write J unfolded equations and draw the corresponding unfolded data flow graph. Okay, so first write J unfolded equation, and for that set of equation draw the corresponding unfolded data flow graph. Okay, that what we have done. For this we have written two equations, and then we have used the concept that delay will be j times slow, and then we have drawn this circuit. Okay, so this method is good as far as number of equation is less and system is less complex. Okay, but for complex system and a large value of j, this method is not feasible, so we have to go for graph based technique for direct unfolding. So we will discuss this graph based technique for direct unfolding. Okay, so you have to follow two steps to convert any given program to a j times unfolded program. Okay, here the word program or DSP systems are used interchangeably. Okay, so step 1 is for each node u in the original DFG draw j nodes u0 u1 uj minus 1. Okay, so simple circuit is described by its data flow graph. So it has two nodes, node u and v, and delay element, number of delay element in between is 37, and suppose we want to unfold it by a factor 2. So for each node u means for this circuit or this program is having two nodes u and v, you have to draw j nodes u0 u1 up to uj minus 1. So we have to draw two nodes, so u0 u1 for this node and v0 v1 by for v0 v1 for this node. Okay, so for each edge u to v with w delays in the original DFG draw j edges. Okay, so if there is one edge connecting u to v, so in the unfolded version, two times unfolded version, there will be two edges connecting u to v. Okay, and ui will be connected to v of I plus w mod j. Okay, so u of I, that node will be connected to v of I plus w mod j, and what will be the weight of this edge? That will be given by the formula I plus w divided by j, and this is a floor function. So this represents floor of x, and which is the largest integer less than or equal to x. So for example, floor of 11 by 4. Okay, so 11 by 4 is 2 point something. Okay, so the largest integer less than or equal to x, so that will be 2. And this is a mod function that will give the remainder after the division. Okay, so you have to do this and this thing for I equal to 0 1 till j minus 1. Okay, so now for this circuit or this data flow graph, given that j is equal to 2, so value of I will be 0 and 1, and then we have to calculate I plus w mod j for I equal to 0 and 1, and I plus w divided by j. We have to take the floor value of this for I equal to 0 and 1, and w is number of delays in the original DFG. Okay, so for this edge w is 37, so w is 37. Okay, so for I equal to 0, 37 divided by 2, so remainder is 1, and for I equal to 1, 37 plus 1 is 38 divided by 2, remainder is 0. Okay, this value is 1, this value is 0, and yeah, then we have to calculate this function. For a I equal to 0, 37 floor 2 is 18 point something, so we have to take 18, and this is 1 plus 37, 38 divided by 2, so exact value is 19, so we have to take 19. Okay, so now this information that is calculated using this formula I plus w mod j, this information will be used to connect the node ui and vi. Okay, so this u of 0 will be connected to v of 1, so u of I will be connected to v of I plus w mod j, so u of 0 will be connected to v of 1, and u of 1 will be connected to v of 0. Okay, and this is the number of delay element on that edge, so 0 to 1, this is the edge, and 18 is the weight of this edge. Total number of delays in this 2 times unfolded version is 19 plus 18, that is 37. Okay, and this is same, so unfolding does not change total delays. In this circuit the total delay was 5 plus 4 9, and in the original circuit it is also 9. So by using the same algorithm I will transform this circuit to this one. So and DFG for equation y equal to a of y n minus 9 plus x of n is shown at this point, and we have to unfold it 2 times, so j is equal to 2. Okay, so in this circuit node A and B are input and output nodes respectively, and node C is adder node and node D is a multiplier node. So to unfold this DFG by unfolding factor 2, you have to draw the 8 nodes, that is AI, BI, CI and TI for I equal to 0 and 1. Okay, so AI, A1, sorry, A0, A1, C0, C1, B0, B1, and so for each node in the given graph you have to draw 2 nodes in the unfolded version. Okay, and after that for every pair of nodes connected by a edge you have to calculate I plus w mod j. Okay, so ui and v I plus w mod j, Okay, so u of I will be connected to v of I plus w mod j, and the weight of this edge will be given by floor value of I plus w divided by. Okay, so the first edge is between node A and C and weight is 0. So for I equal to 0 and 1, w is also 0, so 0 plus 0 mod 2 is 0, and 0 plus 1 mod 2 gives 1, remainder is 1, and 0 by 2 is 0, and 1 by 2 is 0.5, so you have to take integer value, so this is 0. Now for h between C to D, w is 9, so you have to perform the same calculation for I equal to 0 and 1, so 0 plus 9 divided by j. Okay, so j is 2, so 0 plus 9 divided by 2, so remainder is 1, and for I equal to 1, 1 plus 9 divided by 2, 10 by 2, remainder is 0, and for same value the quotient part is 4, so you have to take 4, and for this the quotient is 5, so you have to take 5. The edge between C to B, w is 0, and the calculated value is shown in the table. Okay, so at this, for this w is 0, and for this w is also 0, so the values will be same. Okay, so you can use this same value. Just for explanation I have drawn this table. And for h between D to C, w is also 0, so same value. Okay, so for 4 different edges, 4 tables are drawn, and you can see that w is 0 at this point, at this point, and this point, and the values are same, so no need to calculate again and again for the same set of values. You can just calculate it once and you can reuse the result. Okay, so just for explanation purpose I have drawn for all the edges. So we will use this information to draw the unfolded version. So we have already drawn the 8 nodes in step 1, and now we have to connect these nodes according to this value. So for A to C, A of 0 will be connected to C of 0, and A of 1 will be connected to C of 1, and weight of both the edges will be 0, so A0 to C0 and A1 to C1. For C to D, C0 will be connected to D1, so C0 is connected to D1, and weight of the edge is 4, so 4D, and C1 is connected to D0, so C1 is connected to D0, and weight is 5, 5D. And C to B, C0 will be connected to B0, so C0B is connected to B0, and C1 is connected to B1, C1 is connected to B1, weight of both the edges, the weight is again 0, and for D to C, D0 will be connected to C0, D0 is connected to C0, and D1 is connected to C1 with weight 0. Yes, so this is the final unfolded DFG, that is representing 2 consecutive iteration of this given DFG, and we have already verified it mathematically. So total delay in this graph is 5 plus 4, that is 9, and the delay in this given graph is 9. Okay, so again it is verified that number of delays is same.